Hi, how's it going? I want to start off by saying that I don't mention my Patreon much. I don't even remember to put a link in most of my video descriptions, although I sometimes add it after the videos have probably gotten 99% of the views they'll ever get. But I do have a patron who has been contributing for quite a while, and I just wanted to say thanks. I appreciate you. Also, 10,000 subscribers flew by, so thank you all. One of the reasons this channel came about is because I was researching something and I looked for info on YouTube, as you do, and I didn't find anything. So I made a video about it myself so the next person looking might find something. That's the basic story of this video as well. I was researching multimeters and I stumbled across this TNP278 from Techni-Pro. The specs and features on the 278 seem pretty good for the money. But is it any good? Techni-Pro is a brand owned by Test Equity, and I could find very little info on these meters, so I decided to check it out and make a video. Maybe the next person will find this info helpful when they go looking. So let's get into it. This isn't a super cheap meter, but I found it on sale for less than half the price of many big name meters with this level of features and specs. I'm sure there are other budget brands with similar features, but the Techni-Pro could still be a good option. I won't list out every spec, but I will go over the highlights. It is an industrial multimeter that claims 1000 volt Cat3 and 600 volt Cat4. It also has an IP67 dust and waterproof rating. It is a 50,000 count meter with very good basic accuracy specs. Technically, it should also be pretty fast, as it claims 10 readings per second nominal. It also has built-in memory and can store up to 10,000 readings. Well, 9,999. You can set it to save a reading every so many seconds, and you can set the number of seconds between readings, or you can set it up to save a reading every time you press the store button. It can measure current at up to 10 amps and down to the microamp range. It has a 50 ohm resistance range for better low ohm resistance than a lot of meters, though don't expect a meter like this to replace a dedicated milliohm meter. It has a 4 to 20 milliamp mode, which can measure 0 to 25 milliamps, displayed as a percentage of negative 25 to 125%. It has a triple display with a bar graph, and it has built-in Bluetooth to connect with a mobile app, but the app is only available on iOS, and I don't have any iOS devices. Rather than a pouch, this meter comes with a hard plastic case. The case is a little bit cheap feeling, but it's not bad. It comes down to personal preference whether you're going to like the hard case or if you'd rather have a soft pouch. It comes with a K-type thermocouple because this can do temperature measurements, as well as an adapter for K-type thermocouples. It also includes plugs for the jacks you aren't using, and I wonder if they are required for the waterproof rating because they have little ridges on them to seal the ports, and the included leads have those same ridges. The manual doesn't say that these plugs or the special leads are required to meet the waterproof rating, so I can't say for sure. Maybe the jacks are sealed and these are just to keep junk out of the jacks. Another thing that's hard to say is what this USB stick is for because it wasn't even listed among the included items. The plastic is translucent and I can actually see that there is an antenna in there, so I'm thinking it might be a USB Bluetooth adapter. It also includes a CD, which was listed among the included items, but it doesn't say what it is. There's nothing in the manual about these items. I'll test it out later, but I suspect this might be PC software and a way to connect the meter to a PC. Pretty cool if so. The banana jacks are solid, they are not split jacks, so they should be plenty durable, but there isn't going to be any kind of a warning if you plug your leads into the wrong jack based on the selected mode. There's no warning of any kind, actually, when you switch modes to check your leads or anything, so no big deal, just be careful. Doesn't have any kind of warning built in. The included leads are just okay. They are PVC insulation, and they are fairly supple, and the probe tips are pretty sharp, but they are a bit inconsistent and scratchy. If I put the meter into continuity mode, it crackles and goes in and out of detecting continuity if I slide the probes together, and if I just tap them together, it's hit or miss. If I swap leads, there is a clear difference. Replacement leads aren't terribly expensive. Even USA-made ProbeMaster leads are around $25, and I'm sure you can get something decent for cheaper than that. But just note that even the much maligned, cheap, super stiff leads that come with cheap Fluke meters these days are more consistent, despite not being gold-plated. The 278 uses a 9-volt battery, which I can live with, but it's certainly not my favorite. The selector knob is a bit stiff, but I imagine that's due to the seals required for the IP67 rating. And with that in mind, it doesn't feel too bad. The display is reasonably crisp, and the backlight is pretty bright. Doesn't maybe seem like it in this in this room because these lights are very bright that I use here, but the one thing about the backlight is that it does make the display maybe look a bit more washed out at angles where it already looks a little washed out. But works well, pretty bright. It's a small thing, but I really like the exit button on this meter. When you have the meter in manual range, min-max mode, recording mode, relative, whatever, you can always just push the exit button and get right back to normal. No need to cycle through all the functions or turn the selector knob back and forth to sort of reset the mode you're in. Just press exit. It's a very convenient feature in day-to-day use. I also like that rather than having to hold various buttons when you turn the meter on to change various features, there is just a setup menu that you can get into at any time to turn the beeper on and off, change the auto power down timer or turn it off, and change the backlight timer. You can also set low and high measurement warnings, so if you're checking a bunch of components or monitoring something, you can set up the meter to beep if the readings go above or below the levels you set. Kind of cool. Overall, measurements are quite fast, even with auto ranging, though the auto ranging does slow it down a bit at times. When set to a fixed range, the readings are very fast. It's not uncommon for capacitance measurements to be slower, and that is true with this meter. I'd call the auto ranging in capacitance mode downright slow. Capacitance also has only average accuracy specs, unlike the quite excellent specs in other modes. It does have a wide range of capacitance it can measure, though, so it's not all bad. I don't have fancy reference components or high-end gear for accuracy testing, but I'll do my best. I'll also compare the 278 to a few other meters. I have here a Bryman meter that I've had for several years. I also have a Fluke 87.5 that I used and abused in the field for quite a number of years, as you can probably tell. It has also never been calibrated, so it'll be interesting to see how it compares to the others. I also have a Fluke 107 that I mostly wanted to throw in for a specific demonstration later, but I'll go ahead and put it in all the tests just because, even though it's clearly not a competitor to these others. For this first batch of testing, many of the components were measured with a recently calibrated 6.5-digit bench meter with better accuracy specs than any of these handheld meters on the desk. So as I measure each component, I will put on screen the reference measurement from the bench meter so that you can compare. And I will just say, all of these so far are pretty much spot on. Now we'll check the Bryman with this little test board. Now it's close, but it's reading a little bit higher. Once again, maybe a couple millivolts high. Now the Fluke on this board, I do have it in high-res mode, but it still just doesn't have the number of digits that the other ones have. Reading maybe just a tiny bit low. Yep, maybe about as much low as the Bryman was high. Yep, darn near spot on, but just the tiniest bit low. Oh, that's pretty darn close. Oh yeah, that's that's pretty much right on. The accuracy specs of this are way lower than the rest, so it makes sense that it's a little off. Still not absolutely terrible. Not terrible. Definitely a little bit less accurate than the rest. All right, I've got another little voltage reference board here just for the heck of it. Next is a board with a few capacitors on it. I don't know how precise these are, but once again, I did check them with another bench meter. So let's see how this goes. As you can see, pretty slow measuring it. Accuracy is not too bad. Not perfect, but again, it is one of the weakest specs of this meter. And it's not bad, the accuracy. It's just a little slow. That's pretty much spot on. Fluke seems to jump around quite a lot at the low ranges. Now, at that low range, this one reads really high. Also reads pretty high there. That's much closer. Also pretty close. That's pretty close to spot on. Next up, I just have a few high precision resistors on this board. And I'm just going to set the range and relative out the meter resistance for the two lowest readings here, so we can get as close as we can. All right, and exit that, so it's just back to auto range. And now we'll test some diodes. I turned one of the lights off so you can hopefully see them light up. They're not super bright in here with these lights on, but hopefully you'll be able to see it. Very, very fast. Lights it up. This little RGB light's pretty dim, but you can see it's lighting it up. And the voltage reading comes up on the meter almost instantly. And they all light up. The Bryman does light them all up, but they're not as bright. The reading is fast, maybe not quite as fast, but it's close. The Bryman lights the lights, but they are very dim. The little yellow one I can barely tell is on. The Fluke lights them up, I would say, noticeably brighter than the others. Yeah, definitely noticeably brighter. The little Fluke 107 lights the red light, not very bright. It lights these, but they are very dim. You know what? That one I don't know. I don't think that one's lighting. Nope, the meter isn't even reading it. Nope. That one lights, but the meter doesn't read it. And this one doesn't light or read it. Now, just for the heck of it, to show some more DC voltage, I've got the meters all connected to my power supply. It's not a super accurate power supply, but at least we can have the comparison of all the meters. Right now, I've got it just putting out 500 millivolts. You can step that up to 1 volt. Four volts, 5, 8, 10, 30, 40, 50, 60. Now I have the meters hooked to a waveform generator that is currently putting out a smooth sine wave at 60 Hertz. With a smooth, symmetrical sine wave, you can see that all the meters give similar readings, including the non-true RMS one. But when I switch to different waveforms, you can see that the readings on all the meters change, but you can see that the non-true RMS meter is now reading different than the rest of them. And not all waveforms will cause a non-RMS meter to be off the same amount or in the same direction. With this waveform, you can see that the non-true RMS meter is now reading low. Just thought I'd demonstrate that with a clean AC sine wave, a non-RMS meter will give good readings, but it will diverge when the waveform isn't a smooth, symmetrical sine wave. Getting back to a normal sine wave, let's step up the frequency to see how long each meter can hold on and show a stable voltage reading. Up to 500 Hertz, they all still seem to be reading pretty close. At 1 kilohertz, again, they're all still reading fairly close, though the Fluke 107 might be dropping off just a little bit. At 5 kilohertz, the 107 has dropped off a little more, but the rest are still reading pretty much the same. And you can see that due to the triple display on the Techni-Pro, we are actually seeing the frequency up at the top here. At 10 kilohertz, we are starting to see a little bit of divergence among the rest of the meters, but not drastic. At 20 kilohertz, we're now starting to see much larger divergences between the meters, and it's kind of hard to say for sure which one is the most accurate. At 30 kilohertz, it seems like the Techni-Pro may be reading a bit high. The Bryman has fallen completely away, and the Fluke, I would guess, just because it's the closest to what it was at the lower frequency, I would guess that the Fluke 87.5 is going to be the closest to correct at this point. At 50 kilohertz, the number on the Techni-Pro has gone up a bit, and the number on the Fluke has actually gone down a bit. At 100 kilohertz, they're starting to diverge even more. At 500 kilohertz, the Techni-Pro has gone up a little bit more in the reading, and the Fluke 87.5 has dropped off entirely from being able to show a reading. And back to 60 hertz, they're all right around 5.3 again. Now, switching out of voltage just to frequency, let's see how high of a frequency each of these meters can measure, with the understanding that they are just connected with regular leads and nothing's shielded or anything like that. Again, starting at 60 hertz, let's go up pretty high right off the bat just because I think they'll all measure pretty high. So up to 1 kilohertz. They're all showing 1 kilohertz, no problem. Let's go up to 100 kilohertz. Some auto ranging there, but they're all showing 100 kilohertz. 500 kilohertz, they're all showing 500 kilohertz, no problem. 1 megahertz, they all show no problem. At 1.5 megahertz, the Fluke 87.5 has dropped out. I went back down to 1.1 megahertz, and the Fluke 87.5 is back in it. Reads 1.2 okay, 1.3, even 1.4, but at 1.5, it drops out. So the Fluke 87.5 can only go up to 1.5 megahertz. Interestingly, the 107 is still reading, so let's keep going. 2 megahertz, no problem. At 5 megahertz, the Techni-Pro, the Bryman, and the 107 are all still reading. At 10 megahertz, the Bryman and the 107 have dropped out. The Techni-Pro is still reading okay. At 20 megahertz, the Techni-Pro is still reading. 25 megahertz, it reads just fine. But what I have found is that at 26 megahertz, it will read. Anything above that, so we'll go to 26.5, and it drops out. So anything up to 26 megahertz, the Techni-Pro will read fine. Anything above that, and it actually glitches out, and it won't actually come back until you turn it off and back on. So up to 26 megahertz, no problem. Anything above that, it does glitch out a bit. And if I drop down to 1 megahertz, all of them come back. And now I've specifically dialed in 1.329 kilohertz just to see how they would all read, and they're all reading pretty accurately. The 107 is like 1 digit off, but that's probably within spec. And now I've set it much lower, just 61.35 hertz, and here's how they all read. And now I've set them all to read duty cycle. I currently have the function generator set at 50%. I'm going to go ahead and scroll that up and down just a little bit so we can see how all of these read. There's 40%. There's 30%. 20%. 10%. And 3% duty cycle. That was all at 100 hertz. Let's dial the frequency up to, say, 1 kilohertz. Still at a 3% duty cycle. And you could see that the 87.5 is starting to read a little bit off, and the 107 is very far off. Again, we're putting out 3% duty cycle at 1 kilohertz. Let's go up to 5 kilohertz. At 5 kilohertz, the Techni-Pro and the Bryman are still reading pretty good. The 87.5 is a little bit further off, and the 107 is pretty far off. Go up to 93% duty cycle. Yeah, at 93% duty cycle, 2 kilohertz, Techni-Pro and the Bryman are both reading pretty darn good. The 87.5 is a little off, and the 107 is quite a bit off. Now we're at 98.5% at 5 kilohertz, and 87.5 a little bit off, 107 pretty far off. Techni-Pro and Bryman is pretty much spot on. And just for the heck of it, let's see how far the Techni-Pro and the Bryman can go. We're still at 98.5% 0.5% duty cycle. I've gone up to 10 kilohertz. Let's go up to 20. 50 kilohertz. 75 kilohertz. Now at 500 kilohertz now, both the Bryman and the Techni-Pro are starting to drop. At 1 megahertz, the accuracy of the Techni-Pro has gone down more yet. We're still at 98.5% duty cycle, and at that point, the Bryman just doesn't read at all anymore at 1 megahertz, for what it's worth. And I've dropped back down to just 100 hertz, 98.5% duty cycle, and here's how they read. Now I have all the meters connected in series to my DC power supply so that I can compare the amperage readings between them. I don't have any calibrated measurement of the amperage, so we'll just be comparing them. I will be starting out in the microamp range. My power supply won't consistently put out a constant amperage in the microamp range, so I have to kind of trick it. I can get it to put out microamps, but not at any specific microamp level. So I'll just get it to put out the levels of microamps that I can, and we'll look at it on the meters. I don't expect the 107 to show much because it doesn't actually have a milliamp or microamp range, only amps. Now, it still does have milliamp resolution, but when we're dealing with microamps, we probably won't see much. So the Techni-Pro, the Bryman, and the Fluke 87.5 all show pretty similar readings. I did notice that the Bryman is quite a bit slower to update the amperage readings. Still in the microamp range, so 101 microamps. And they're all reading pretty much the same, so I would expect them all to be pretty darn accurate in the microamp range, with the Techni-Pro and the Bryman having a bit better resolution than the Fluke. Actually, does it have high-res mode? There we go. We've got a high-res mode on the Fluke. No problem. Yep. They all seem to read microamps just fine. No issues. Now we're in the milliamp range, and I'll start putting out milliamps with my power supply, and we'll see how they read. My power supply is not good at putting out anything less than 2 milliamps, and I don't think it's even accurate at 2, because it currently says it's putting out 2, and I doubt every one of these meters is wrong almost to the exact same digit, so pretty sure these are going to be more accurate than this. But we'll step up through the range and just see how they do showing milliamps. And you can see that the 107 is actually now showing a reading. And in the milliamp range, we can once again see that the Bryman is quite a bit slower than the Fluke and the Techni-Pro. No, it doesn't look like the Fluke goes all the way to, I think it's 200 milliamp range on the Fluke, so it won't read 250. But yeah, milliamp range, they all look good. And finally, now we've got them all into the amp range, so let's start throwing a little bit higher currents at them and see how they do. It's 500 milliamps. Oh, this is in AC. Well, that doesn't do any good. So there's 500 milliamps. 1.5 amps, 2.5, 3.5, 4.5. And then we'll just go up to the maximum of 5. So there you go. Make of that what you will, because I don't have a reference other than just comparing the meters. Overall, after all the testing and my general use with the Techni-Pro, I would say that it's pretty fast, though maybe a bit slower than the other meters in some modes, but it is also faster in some. The accuracy is also excellent, and it can read higher frequencies than the others here, although it does seem to lock up if you go above 25 megahertz, so be aware of that. But let's open it up and take a look inside. So I got the meter apart, and a couple interesting things right off the bat. This is the Bluetooth module, which was just stuck onto the board with some little standoffs. And in case you doubt me that this is the Bluetooth module, it actually says Bluetooth right on the back of it. So not a lot of doubt there. And I took this off to better see the chip that's there. There is some shielding, and underneath there, you can't really quite see it, but underneath there is a quality brand resistor network underneath there, so that's kind of nice. We do have some protection down here. A couple interesting things. This ground, the common input, very interestingly, this has a wire that comes all the way up and connects to the board up here. Not something I've seen before, kind of interesting. Current shunt. This actually is a 30 amp resistor. I haven't really seen a resistor that large in a meter like this before. So it's just a 10 amp mode, and they say it can handle 20 amps for a short time. But interestingly, it's actually a 30 amp fuse, so be aware of that. And then a smaller fuse for the low amperage modes, 500 milliamp fuse, and it's also a physically smaller fuse design. We do have some Zener diodes and a little clamping diode network here for the amperage mode. There is a PTC, pretty sizable one compared to what I've seen in a lot of meters. Some various resistors down here, maybe current limiting, hard to say exactly, and a MOV there. So definitely better input protection than I've seen in some of the super cheap meters that I've opened up, but nothing, groundbreaking or revolutionary either. On the board here, you can see the two pads for the battery contact. And down in this channel is a seal all the way around for the weather sealing, and the screws, they do just go into plastic. There's no metal inserts, but the screws all have washers and little seals on them as well for that water and dustproof rating. A few odd little things like this wire running up here, and these resistors weirdly seem a little bit beat up, but overall not bad. I am seeing, quality name brand things, analog devices and such. So yeah, inside looks pretty good. I do see a couple trimmer pots. Even though the input protection probably isn't quite up to the standard that I've seen in other meters, I think it's all probably well enough contained that if something did fail, it probably wouldn't fail violently enough to actually hurt you. But just note that the input protection maybe isn't quite up to the standards of something like a Fluke meter, but it's not bad. I've definitely seen worse. And I just thought I'd show this too. The battery compartment does have metal inserts. I suppose you will be accessing that probably more often than having to get inside and replace the fuses, for instance. So while the case screws just go into plastic, the battery compartment screws do have metal inserts, and the compartment has kind of little molded fences here to make sure, or make it more difficult to install the battery backwards. And the battery compartment is actually a bit fiddly to get on and off. It kind of seems like it wants to hang up. There we go. Overall, this is a pretty good meter. It has some nice features that are convenient in day-to-day use, like the exit button and the ability to change settings without remembering button combinations, and the simple mode to log readings internally. It's pretty fast, it has good resolution, and it's very accurate. And it can measure pretty high frequencies. And I did verify that the included CD contains a simple but functional program to remotely view, log, and save meter readings. It's pretty simplistic, and it only updates about once per second, but it's easy to use, and I wasn't even expecting it to be included. It's better than nothing. The USB stick does seem to be a wireless dongle, though I didn't need it. My test computer has Bluetooth built in, and the meter showed up and connected immediately. The meter is reasonably well sealed, and the build quality is okay. It's not amazing, but it feels solid enough, and it seems to use reasonable quality components. I don't love the 9-volt battery power, and it's probably worth getting a better set of leads since the included ones don't do this meter justice. It doesn't have a beeper in diode mode, which is something I noticed and didn't mention before, and it doesn't have warnings if you put the leads into the wrong jacks, though the trade-offs for that is arguably more durable, solid jacks. It's certainly not a perfect meter, but I think it's worth consideration if you're in the market, especially for the sale price I found. It's not going to rival the quality of higher-end brands, but that makes sense because it's a lot less expensive. Who knows if it will stand up to a couple decades of abuse like my Fluke 87 has, but as it stands, I like it. So hopefully that was helpful. If you have any questions or if there's anything else you'd like me to test out with this meter, let me know. And as always, thanks for watching. Take care.